Before I take you through how I made this and take you through the code, I'm just going to give a little demonstration of how it works. So basically you can change the colors by turning this little potentiometer on the top that I put in. So we can go through basically around the outside of the color wheel from green and then back to green again. So we're doing like a circle around the color wheel. And then to put it in multicolor mode, we press this little button on the top and we can change the speed at which the colors change by turning this little potentiometer again. So that's fast, and then we can slow it down, and then we can just make it still, or we can make it change quite fast. All right, so now I'm going to take you through how I made this and the code. Hey everyone, so I'm just doing a little fun build today with addressable LEDs, and I'm going to make a lamp out of this vanish bottle here, this old vanish bottle which is now empty, and I'm going to use these ping pong balls for diffusers for the LEDs, and I've got these addressable LEDs and I'll link these in the description because these are pretty good, and they're not like a strip, which means that you have to put all the LEDs close together. These ones you can make them a little bit further apart so we can kind of stagger them around the edges of this bottle. I'm going to take that label off, by the way, and then I'm going to use an ESP8266 to control it all, and I might throw in like a potentiometer or something just to use it to change the colors, but we'll see how that goes after I make it. So I've taken the label off now and I've cleaned it with a bit of toothpaste just to get rid of the soapy smell, and also a bit of hand sanitizer. And I've got these strips that I printed up with just a letter O on them, and I'm going to wrap this around this just so I know where to drill the holes. Basically I'm going to wrap this around here now and then drill the holes. These LEDs, they're 12 millimeters, so I need to drill 12 millimeter holes in here. So I've stuck these bits of paper, these strips of paper with the O on them around the outside, and I'm just going to go and drill small holes, and then I'm going to come back and do larger holes to get these 12 millimeter LEDs through. So I've drilled out all these holes now, and I guess the next thing is to paint it. I'm going to try paint it black just so it doesn't reflect the light, because it's a lamp and I want the light to emanate from it. I want the colours to be like the actual colours from the globe, to be more, I guess, precise, for want of a better word. Okay, so I've got 23 holes here, and these, like I said, these are 12 millimeter holes. And to drill them, I used one of these staggered drill bits. So these staggered drill bits are good if you're drilling through plastic or aluminium. I've used them before. And then I'm going to need a strip here, like of these lights, these addressable LEDs. And I'll put a link to these in the description. But these have got enough distance between them that we can kind of spread them out. So I'll make a strip of 23 of these. And we've got 3 wires. We've got red for 5 volt, white for earth, and green is the data wire. And I'll just solder on a few connections there so I can connect them up to the ESP. And then I'll stick them inside the lamp. And I'll show you what that looks like. I'll put some ping pong balls over them. So let's put this over here actually. It's such a mess in here. And we can stick this kind of on the inside, and that's going to kind of stick through there like that. So I'm just cutting some holes in these ping pong balls to use as diffusers. I'm going to use the ping pong balls as diffusers. Bitluni puts the holes in by poking the end of his soldering iron through them, and I tried that, but the fumes were very toxic, so I decided to use the scissors instead. So this is the strip of 23 addressable LEDs that we've cut off, and this is the input here. So I'm just going to solder on some wire for the 5 volt and earth, and then I'm going to connect one of these jumper cables onto the data wire just so I can plug it in straight to the ESP. And the ESP microcontroller, whether you're using the 8266 or the 32 or the Arduino, whatever you're using, can usually drive between about five or six of these lights. But if you've got any more than that, you've got to have them off a separate voltage source. Alright, so I've just got a demo sketch running where I'm just changing the colours of the 23 lights at the moment. And I'll just show you how I've got it powered. I've got it powered with this USB cable. And what I've done on the USB cable is I've cut the USB cable, the end off it, and I've soldered the 5 volt and ground wires from the LED strip to the USB cable. And then I've also soldered on some jumper wires so I can take those to the ESP8266. All right, so we've put the LEDs in the container and coming through the holes, and we're just gonna put these. We've just put these ping pong balls over the top of them, like that, and so it looks like that. So that's what it's gonna look like when it's all lit up. So I put the ping pong balls on with some super glue on the outside, and I've got the lights on the inside, and then this power cord's coming out here, and it also connects to the ESP32 and the data line for the ESP32. So I'm going to have to work out the best way to put it on. I might just drill a hole in the side here and bring the power cord through there, and then this is the lid. And I might put it upside down like that, and then on the top I'll put this potentiometer just to change the color, and then a little push button as well to change the mode from multicolor to single color. And I'll have this is my ESP8266, I'll have it in the bottom like that in the lid, and then I'll just have that on top of that. So I think that's what I'm looking at doing at the moment. So I'll put all that together, and hopefully in the next scene we'll have all this working. I've got everything wired up, and before I test it, I'm just going to show you how I've wired everything up. So here's the potentiometer, which I'm going to use to change the color in single color mode and the speed in multicolor mode. And the middle wire of the potentiometer goes to A0, which is the analog input, and then I've got the outer 2 wires to ground at 3.3 volts, and then I've got this little push button here, and I've got this wired between pin 14 and ground, and I've got a little 220 ohm resistor connected to between the push button and ground, just to give it a little bit of protection. And I'll go over all these connections. I'll put them all as a comment in my code. And then from pin 14, which is the one that the push button's connected to, I've got this connected to the 3.3 volt as well here, but I've got it connected through a 10 kilo ohm pull-up resistor. And that's just to keep it high, because otherwise it kind of floats around and goes up and down a little bit. If it's not actually pulled up high. And I tried using setting it as input pull up, but it didn't seem to work. It seemed to still be floating around. The data connection from the addressable LEDs goes to pin 12 of the ESP8266. So now I'm going to switch it on and see if it works. Alright, so the reason it didn't work is because I didn't have the ESP8266 connected to any power. Alright, so now it's connected to power. I'll switch it on, I'll see if it works. Okay, there we go. Now press this button. Let me put that in there. And that's single color mode. All right, I'll show you that from the side now. All right, so when we turn the potentiometer, the color's supposed to change. And then when we press this button, it goes into multicolor mode. Okay, now if we turn the potentiometer, it changes color much faster. And then we can make it change color more slowly by turning the potentiometer until we turn it to the end and it doesn't change at all, hopefully. Before I go over the code, I'm just going to point out this project by Bitluni, which is the one that inspired me to build this lamp. And I'll link this in the description, and it's really worth watching because it really is a very good project. I'm just going to go over the code for the lamp with you, and I guess at the top of the code, as the first comment, I've just put in the pin connections for the lamp, and there's nothing too complicated. I'm using WS2812 addressable LEDs, and the data pin I've got connected to pin 12 of the ESP8266. I'm using the NodeMCU dev board version. Now I guess it's probably easier if I show you on the fritzing diagram. So this is my, I'll start from the left. So this is my LED, and I've just connected the data pin. I've got this powered off plus and minus 5 volts, but I've just got the data in coming from D6, which is also pin 12, and then this is actually data out is just going to the next LED in the strip. So there's 23 of them all together. And then this is the button here, and the button I've got connected to ground by a 220 ohm resistor, and that's just a small resistance just to make sure that when I press it there's no large current shocks and I don't destroy my board. And I've got this connected to D5, and I've got D5 pulled up to 3.3 volts with a 10k resistor. And then the potentiometer, I've just got the middle pin connected to A0, which is the only analog input on the ESP8266 dev board. The ESP32 has a number of them, but this only has one. And then I've got this one 3.3 volts and this one connected to ground. Okay, but so I put all the pin connections in the comments here, and with that all set, I'll go through the code. So the first thing I do is I include the library, the NeoPixel library. I'm using the Adafruit NeoPixel library, and I've got no idea why this is in there, but that was in the examples, and I've just always left it in there in the example sketches that came with the library. I included the math function just because I'm using a modulo. I was using a modulo, although I don't know if it's that necessary. Pin 12, that's the pin I've got the LEDs connected to. I've got 23 pixels because I'm using a 23 pixel strip. I've got 23 LEDs. Pin 14, that's for the button. Then I instantiate my my LED strip here so I can address it. I can set the colors. HSV color, that's to set the HSV. Multicolor is whether I have it in multicolor mode or single color mode. Button state is if the button's been pressed, and previous button state is what was the previous button state, because we don't want the button to be pressed and not change. We want to toggle it, so we want it to change. So if you press it and you hold your finger down, we don't want it to keep on the state to keep on changing. Light speed, this just sets the speed at which the colors change, and last time this is just for my timer. And then the analog input pin, this is where the potentiometer is, and the sensor value is just the read of the analog input pin basically. And then we have the last sensor value because again we want to avoid noise, so if it just changes by 1 or 2, we don't want to change it, we want to have it changing by at least 20. And Q is just an index for setting the color. So we set it up, we start the LED strip, and we set all the pin node. I set this, like I said, I set this to input pull up, but it didn't actually work, it just kind of floated around a little bit. And then button state is digital read button pin, and that should be high because we've got it connected by a pull-up resistor, but that's just my first setting of the button state. And then I read the sensor value and I OR it. I do a logical OR with a 16-bit number. It's just so because this is 10 bits, and it's just like a safety thing. I learned that the hard way, so that can cause bugs. And then I look at the button state, which is if the button is pressed, and if the button is pressed, then of course the button state is false, because when it presses it sends it down to ground. And if it's different from the previous state, I just do this just to stop it from, so if it's pressed it doesn't just keep changing over. So that just toggles the state, and then I delay like half a second just to avoid bounce on the button, because sometimes if you press the button and then you take your finger off, it can bounce around a little bit. So then I set the speed of of how often it changes from between 100 milliseconds and 4 seconds. So I update this Q value, which basically, if Q is updated, it sets it at a different color, because the Q goes in here, J plus Q, which so this part here sets HSV color plus J plus Q times number of pixels divided by 23. So there's 23 pixels, so it's basically 1/23 of 65,535, which is 1/23 of the way around the color wheel. So just bear with me for a couple of minutes and I'll just pull up the color wheel. So this is the color wheel here. So let's look at this one. So what we're doing is we're going around the outside of the color wheel. So 0 is over here at this green, and then we go around the outside, and 65,536 is back here. So if we go around 1/23, that's the next pixel along, and then another 23rd, that's the next pixel along, and so forth. So every pixel, when we're in multicolor mode, moves around 1/23 of the way and then back to its original position. So that's basically what we're doing with the HSV color. And then if we're not in multicolor mode, so basically here is multicolor, but if it's not multicolor mode, then we just set all the pixels the same color. We don't bother adding another color. We just set it all the same color, and that color we get from the sensor value, which is the potentiometer value. So the potentiometer value gets mapped to both the sensor value, the sensor value, which is the potentiometer value, gets mapped to both the color, and gets mapped to the light speed value as well. So it's used for two things, and you can go through that and have a look at it. And if there's any questions, just put them in the comments and I'll happily answer them. But the code's really not that complicated. So basically it just iterates from 0 to the number of pixels, and it sets the color of each pixel. And if we're on multicolor, then it sets a different color for each pixel with this J plus Q, and then Q changes if the color's set to change. And if it's not on multicolor, then it just sets the same color for every pixel, which is just this going around the outside of the color wheel as we turn the potentiometer. Alright, so that's the code, and like I said, if you've got any questions, leave them in the comments, and thank you very much for watching. I'll put all this up on GitHub so you can download it, and I'll see you in the next video.